Myself, Dr. VJD Kalyani, working as Associate Professor in the Department of Computer Science and Engineering of Institute of Aeronautical Engineering. In this video, I will discuss regarding definition and terminology of Module 1. This topic learning outcome is mapped to the course outcome of CO1, which is identify the appropriate process model approaches and techniques to manage a given software development process. Define the software. The software is considered as collection of instructions, data structures, and documentation. It is not only simply the programs that are related to solve a specific objective, but it is associated with the data upon which these programs must be operated and the necessary documentation. Software can play dual role. One role is as a product. The second role is as a vehicle to deliver the product. As a product, the software delivers the computing potential across network of hardware, and it enables hardware to deliver the expected functionality. And as a vehicle to deliver the product is the second role. In this, the software provides system functionality, it controls other software, it helps build other softwares. So, as the software is majorly focusing to solve the specific objective or functionality as a vehicle to deliver the product to serve the customers. The basic characteristics of software is developed or engineered, and it is not manufactured in the classical sense in the industries. Software does not wear out. Whenever continuous using of the application, it won't be wear out as like in the hardware. Most software is custom built and it is developed according to the customer requirement rather than being assembled from existing components as other hardware features that can be assembled according to the circuitry in the industry. So, the basic difference between hardware versus software is as the time processes, the failure rate must be increased in case of hardware. So, it can be wear out. In case of software, through maintenance, the continuous working and accurate and efficient working of the application continues over the time. The second term is explain applications of software engineering. Software engineering can be used in many applications. The popular applications are cloud computing. So, software engineering is used in cloud computing, cyber security applications, big data, and many more. And it is also used to solve the agriculture, aviation, and business problems. So, used in the industries as well as in the management, education, health sector, and also government sector. So, the application development is majorly created the mobile apps, web applications, as well as desktop applications. It is not only that, for accounting purpose also we can use the software. The spreadsheets are the essential skills for the engineers and are used to manage the data produced by the companies and to manage the accounts for the business organizations. Web browsers are the common type of application software and are pre-installed on most systems. Word processors can use artificial intelligence to predict the word and suggest synonyms and proofread work. And the softwares can also be used in architectural design. So in this, it is a critical task in the software engineering. So especially for the system that must operate correctly. So the real-time applications need the computer architecture that can best suit, and it can increase the efficiency and performance of the application in terms of time complexity as well as space complexity. The next application is databases. Databases allow users to access data from anywhere and can also be used to store information for developers. So the backend plays important role in the application, and the data warehousing and knowledge discovery can also be implemented with software engineering. Another application of software engineering is embedded systems. Embedded software is used to control the devices and machines other than the computers. So, such as the cars, automated cars, telecommunication network, industrial robots, washing machines, microwave ovens. In that other circuits, the computers or the software code is used to control these devices. Next term is define Agile software development. Agile software development is an umbrella term for the approaches to developing software that reflect values and principles agreed by the Agile Alliance, a group of 17 software practitioners in 2001. The Agile software development is software framework that values flexibility, collaboration, customer satisfaction. The Agile Manifesto is majorly the basic principles. These manifesto principles are used in the application development in the Agile software development. So, satisfy customers through early and continuous delivery of valuable work. Break big work into the small tasks. So, the project can be divided into small manageable components. This principle is called separation of concern, so that it can complete it quickly. Recognize that the best work emerges from self-organized team. So, the team collaboration is a major feature of the Agile software development. Provided motivated individuals with environment and support they need, trust them to get the job done. So, team collaboration and the agile team, high skilled and experienced team is required for the Agile software development. Create processes that promote sustainable effort. Maintain a consistent pace of completed work. Welcoming changing requirement even late in the project development. Whenever during the development phase, it must follow the phases like analysis, design, construction and deployment. But here, in the normal traditional software development, if the requirements are changed, it is very difficult to accommodate when they are coming in the late phases of the software project like testing phase. But in case of Agile software development, the changes can be easily accommodated at any phase of the software development process. Assemble the project team, business owners on the daily basis throughout the process, so that the communication between the stakeholders is greatly required for the Agile software development. Have the team reflect at regular intervals on how to become more effective, tune and adjust behavior accordingly. Measure progress by the amount of completed work. Continually seek excellence. Harness change for the competitive advantage. With the help of pair programming, these competitive programming skills must be improved in the team in case of Agile development. The core values of Agile Manifesto are Individual interactions are more important than processes and tools. A focus on working software rather than thorough documentation. Collaboration instead of contract negotiations. A focus on responding to change. In the Agile model, majorly the Agile focusing on software development approaches based on iterative development. Agile method breaks the task into smaller iterations or parts do not directly involve long-term planning. So, the part that can be used in the iteration to produce is generally referred as sprint, which can be developed within short span of time. The project scope and requirements are laid down at the beginning of the development process. So, plans according the number of iterations and the duration, the scope of each iteration are clearly defined in advance. So, the Agile model generally consists of these phases. The brainstorming, which is generally used for requirement analysis. Design is to model the project under development with variety of case tools and UML diagrams. Development of the source code to solve the problem. Next is the it must has to quality assess. The testing must be performed at variety of levels like unit testing, integration testing, system testing and user acceptance testing. After user accepting the project, it must be deployed at the customer site for using by the customer. So, the Agile software development majorly consists of these phases. Meet phase, which is used for the major communication purpose for requirement gathering, feasibility study, prototyping. Plan for the budget, resources and the teams. Design is used to model or visualize the features of the software development. Development is used to develop the source code. Test is used to verify this developed source code is functioned according to the user requirements. This evaluation is carried out and that developed software is deployed in the customer site. So, the phases of the Agile process model are generally concept, inception, iteration, construction, release, production and retirement. Next definition is how project is explained in software engineering. A project is a set of tasks to be completed to achieve an objective. So, it must be the effort that can be accomplished to perform day-to-day transactions of any business organization. Projects have defined scope and deadline. So, an example of project is developing a website for an university or any HR process is the examples of the project. The project scope is a big activity comprising small activities done to create value in the form of product or service. These activities do not have predefined model. They are very contextual and asynchronous. It includes customized planning, exploration, ideation, research, and discussion regarding the achievement of defined goals. So, depending upon the size and scope of the project, the number of project stakeholders will differ. So, the benefits of a project is projects have a previously defined budget without any unexpected cost. They streamline the teamwork, clarity about what results to be expected. Projects have an end date, which makes organization easier to track the progress of the project. What is process? A process is previously established procedure that is divided into phases and is repeated to fulfill determined objectives. A process is just a list of events that need to repeatedly do in a chronological order. An example of process is hiring a new employee or the steps involved in an online sale. At each step, at least one stakeholder must be involved. The software process framework is a structured approach that defines the steps, tasks, activities involved in the software development. A framework serves as a foundation for software engineering, guiding the development team through a variety of stages and a systematic and efficient process. A software process framework helps the project planning, risk management, and quality assurance by detailing the chronological order of actions. So, majorly, two process framework activities are there. Major framework activities and umbrella activities. Major framework activities are the generally communication, planning, modeling, and construction and deployment. But the umbrella activities are used to assess these major framework activities. So, the process framework can have the process framework major activities, 5 framework activities, and the umbrella activities, which in turn divided into work task, milestone, and escape point for each action or task set. So, tasks can be, they focus on small specific objective. Action is set of tasks that produce major work product. The activities are groups of related tasks and actions for major objective. Explain project management. So, project management is the field of planning and organizing events that have cut-off times for completion. The project manager is the role responsible for getting the team involved and assigning tasks, monitoring resources, coordinating their use in order to achieve the defined objective. The phases of the project management are initiation, planning, execution, monitoring and controlling, closing. Define project metrics. Metrics are majorly used for measurement or quantitative assessment of the processes for the software development. The project metrics describes the characteristics and execution of a project. Examples include effort estimation accuracy, scheduling deviation, cost variance, and productivity. Usually, measures are number of software developers, staffing patterns over the life cycle of the software, cost and schedule, productivity. So, the key project metrics are generally classified into schedule variance, cost variance, schedule performance index, cost performance index, quality metrics, scope metrics, risk metrics, and stakeholder metrics. The key project metrics are schedule variance, which is the parameter used to show how much project is ahead or behind the planned schedule. Another metric is cost variance, which shows how much project is over or under the predefined budget. Schedule Performance Index (SPI) shows how efficiently project is using time. Cost Performance Index (CPI) shows how efficiently project is using resources. Quality metrics show how well project meets the quality standards. What is spiral model life cycle model? So, variety of process models are available. The spiral model is an iterative or incremental approach of software development. So, it is initially proposed by the software engineer Barry Boehm, and it is an evolutionary software process model that couples the iterative development feature and prototyping with the control and systematic aspects of the linear sequential model. So, using the spiral model, the software is developed in a series of increment releases. So, during the early iterations, the additional release may be a paper model or a prototype. During later iterations, more and more complete versions of the engineering systems are produced. The features of the spiral model are the exact number of phases needed to develop the product can be varied by the project manager depending upon the project risk. As the project manager dynamically determines the number of phases, the project manager has an important role for developing the product using this spiral model. It is based on idea of spiral, with each iteration of spiral representing a complete software development cycle from the requirement gathering, analysis to design, implementation, testing and maintenance. So, this is the spiral model which can generally follow in each iteration. Some features are delivered to the customer, and for development of this, the linear sequential model activities must be carried out, and it is a risk driven or risk assessment model. So here the risk management prototype has to be concentrated in the evaluation, and design, code, integration, test, implementation, product development is the second phase, so that the release of the software can be performed. Next phase or next iteration is planned. Next, review the developed process and the object identified for the next iteration. Cost can be assessed in the next iteration. So, the basic phases of the spiral model are: each cycle in the spiral is divided into object setting, risk assessment and reduction are the first two phases. In the objective setting, each cycle in the spiral starts with the identification of purpose for that cycle, the various alternatives that are possible for achieving targets, and the constraints that exist. The next phase in the cycle is to calculate the various alternatives based on the goals and constraints. The focus of evaluation in this stage is located on risk perception of the project. The another two phases of the spiral model are development and validation. Next one is planning. So, in the development and validation is majorly used to resolve uncertainties and risk. So, this process may include activities such as benchmarking, simulation and prototyping. Planning is the final stage. In this, the project is reviewed, a choice made whether to continue with a further period of the spiral. If it is determined to keep, plans are drawn up for the next step of the project. When this spiral model can be used? When the deliverance is required to be frequent, when the project is very large and complex, when the requirements are unclear and complex, when changes may require at any time. Large and high budget projects generally use the spiral model of the development. The advantages of spiral model are high amount of risk analysis, and it is useful for large and mission critical projects. Change requests in the requirements at a later phase can be incorporated accurately by using this model. Customers can see the development of the product at the early phases of the software development, so they can have used before completing the total product. The disadvantages are this project majorly depending upon the risk analysis. This type of model, the developed projects are majorly depending upon the risk analysis. So it required highly experienced experts and more skills are required for the risk analysis. As the number of phases is unknown at the start of the project, time estimation is also very difficult. And the spiral model is complex. It involves multiple iterations of the software development process. That it must be time consuming and resource intensive. Define object-oriented concept, principle and methodologies. The basic object-oriented paradigm consists of the terms like object, class, message, abstraction, encapsulation, inheritance, polymorphism. The object is a real-time element of an object-oriented environment, and it must have a physical and conceptual existence. So it distinguishes it from other objects in the system. State that determines the characteristic properties of the object as well as values of the properties that are the object holds. Behavior is that represent externally visible activities performed by an object in terms of changes in its state. So how these objects are responding to the external stimuli is exhibited with the behavior. Objects can be modeled according to the needs of the manipulation or implementation. The class represents a collection of objects having the same characteristic properties and exhibit common behavior. It gives blueprint or description of the objects that can be created from it. Creation of an object as a member of a class is called the instantiation. A set of attributes of the objects that are to be instantiated from the class. A set of operations that portray the behavior of the objects of the class. The next object-oriented principle is encapsulation. It is process of binding both attributes and method together within a class. So through this encapsulation, internal details of the class are hidden from the outside world through access specifiers. It permits the elements of the class to be accessed from outside only through the interface provided by the class. The advantages of encapsulation is it keeps the data safe, prevents unauthorized access or modifications, allowed control access for the data through methods, and it can also be used for affecting the code and use of it can be prevented. Encapsulation makes code easier to understand and maintain so that the classes need to focus on what a class does, not how to do it. The details are hidden in case of encapsulation. The disadvantages are extra layers are added for the project development. Encapsulation can sometimes make the code a little bit slower. The next principle is message passing. In the object-oriented paradigm, variety of objects are involved. Those objects must be communicated with the message passing technique. Any application requires a number of objects. Those can be interacting in a harmonious manner. So, objects in the system, many communicate with each other using message passing. Message passing between two objects is generally unidirectional. Message passing enables all interactions between the objects. It is essential invoking class methods. Inheritance is the next principle, which is the mechanism that permits new classes can be created out of existing classes by extending and refining its capabilities. So, these existing classes are generally referred as base class, parent class or superclass. And the new class that are generated is generally referred as derived class, child class or subclass. These subclasses can inherit and derive the attributes and methods of the superclass provided that the superclass allows so. So, besides, the subclass may add its own attributes and methods to modify any of the superclass methods. The types of inheritance are generally single inheritance, hybrid inheritance, multi-level inheritance, hierarchical inheritance and multiple inheritance. Single inheritance means subclass can be derived from a single superclass. Consider this example. Students having scholarship is the derived class from the base class of student. Only a single superclass, the derived class must be generated. So, it is a single inheritance. The next type is multiple inheritance. A subclass derives from more than one superclass. Consider this example. Wheel and rubber are the two base classes. From this only a single subclass is derived, that is the tire. So, from the multiple superclasses, one base class is derived. So, it is called as multiple inheritance. Next is multi-level inheritance. A subclass derived from a superclass, which in turn is derived from another class, and so on. This variety is called the multi-level inheritance. Consider an example. Animal is the base class. From this, mammal is derived. This is the derived class, but which in turn used as a base class to generate another subclass of human. So, this type of inheritance is called multi-level inheritance. Next variety of inheritance is hierarchical inheritance. A class has a number of subclasses, each of which may have subsequent subclasses continuing for the number of levels so as to form the tree structure. This variety is called hierarchical inheritance. Consider an example. Vehicle is the superclass which is having three base classes, three derived classes: land, water and air. These are again used as a base class for deriving next level of subclasses which is forming a tree structure. For example, the land base class is used to derive the two subclasses car and bus. The water base class is used to derive the two subclasses ship and boat. The air base class is used to derive the two subclasses aeroplane and helicopter. So, this variety of inheritance is called hierarchical inheritance. Next variety is hybrid inheritance. It is a combination of multiple and multi-level inheritance. So, here consider an example. Person is the basic class. From that, derived classes are employee as well as student. So, which in turn is the single inheritance. But it can be used to derive one more subclass, that is student in turn. So, it can be combination of multiple from more than one base superclass. The derived class can be formed, and it is a multi-level inheritance from the person base class, student, and which in turn used to derive the student in turn. So, the combination is called hybrid inheritance. Next is polymorphism. This principle is originally derived from a Greek word which is means the ability to make multiple forms. Consider an example. The steering can be used in many forms or in many vehicles. So, in object-oriented paradigm, polymorphism implies using operations in different ways depending upon the instance they are operating upon. So, multiple forms can be used. So, polymorphism allows objects with different internal structures to have a common external interface. It particularly effective while implementing inheritance. Abstraction is another principle which is about using objects and classes without worrying about how they work internally. So, whenever you are creating, you cannot only abstract details are the which details are necessary are present, but without representing how they are to be implemented. For example, consider the TV remote. So the TV remote can be need how to use it, but what is the circuitry behind this TV remote we cannot know. So like this, the presentation of details is generally referred as abstraction. The advantages of abstraction is it makes the things simpler. It focuses what is important and what details must be ignored. So reuse the same template for different things. When something goes wrong or needs an update, you can fix it by breaking down broken without messing up everything else. So abstraction helps us to grow our projects without making them messy. The disadvantages are too much abstraction can make things more harder and it is very difficult to understand. So an extra work can be added in the code which slow down the program a little bit. So these abstraction tools can be tricky for the beginners. So in this video, I discussed a variety of definition and terminology terms regarding the module 1 and the references used in this video are this. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.